energy level due to spin-orbit interactions. If we ignore spin-orbit interaction, a spin-1/2 particle is in a spherically symmetric potential energy well and has a series of energy levels corresponding to a given solution of the radial R sub n L of R of the radial time independent Schrödinger equation. Where I put TIS here, it means time independent Schrödinger equation. I write it in that form just to save time. But anyway, there will be a number of degenerate states with different values of the magnetic quantum number m and spin magnetic quantum number ms. The allowed values of these quantum numbers are m equals 0 plus minus 1 comma dot 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 plus minus l, and mj equals plus minus 1/2. So each solution of our radial solution, our radial equation, corresponds to 2l plus 1 different quantum states, all with same energy when the spin orbit interaction is included, all with the same energy. But when the spin orbit interaction is included, the degeneracy of energy levels is changed. To see this, we have an equation here where we're including our spin orbit interaction, and we end up with this term here, and which we can write as this, and L and S operating on the vector we've been through a few times now will result in this, a 1/2 plus 1 h bar squared acting upon the vector here. So the presence of spin orbit interaction causes the states within the same value of L due to different values of J to have different energies. Some degeneracy remains because states with the same value of L and J but different values of MJ have the same energy. For a spin-1/2 particle, each non-zero value of L corresponds to 2 values of J. Normally J equals L plus 1/2 and J equals L minus 1/2. So each energy level with L not equals 0 splits into two. One of the levels is J L plus 1/2, and as this here, 2L plus 1, which we determined before. The degenerate states with different values of MJ is the energy state with different values of MJ. The other is labelled J equals L minus 1/2 and consists of 2L degenerate states. With different values of MJ, the total number of states remains the same, whether we include spin-orbit interaction or not. Including spin, but ignoring spin-orbit interaction, there are 2L plus 1 states for each L. With spin-orbit interaction, there are again 2L plus 2 plus 2L, so 2L plus 1 states. And here, I've just put down in a little table some here, which this may look familiar if you know the periodic table. Our hint is the cumulative sum 2, 8, 1832, or the lengths of the periods or rows in the periodic table. And that's it for this one.